For your homework for these two sections, all right, what I did was I combined 6, 4 into 1. It was A and B, I combined it into 1. And then 6, 5, I combined it into 1. So your 6, 4 homework is not due until Friday morning. But there's 11 questions. 7 of them you can get done tonight. So I would do that and then do the other ones tomorrow. But what you have to do is it says it in the assignment, but you have to graph in Notability. Because all you're doing is picking the graphs on WebAssign. But you actually have to draw the graphs because you're going to have to draw the graphs by hand on the test. It's not going to be multiple choice. It's going to be a joy to grade, but that's neither here nor there. But we're talking today about the graphs of sine and cosine. I need your all's attention. If you need to move your seat so you can pay better attention, then do that now. But I need everybody's attention. If we were to talk about sine in general, sine is what value? X or Y? Okay, sine is your Y value. So we all have the unit circle memorized. Great. I want you to think about the Y values at the 4 quadrants. At 0 or 2 pi, what is the Y value of the ordered pair? 0. And then at pi over 2, it's what? 1. And then at pi, it's what? 0. And then at 3 pi over 2, it's what? -1, okay? I want you guys to think of that. What we're going to be doing is we're not moving the graph left and right. We're not moving it up and down. We'll do that tomorrow. But we're just going to graph a sine curve as it goes around your unit circle. So I want you to notice here. Look at this. This is what a basic sine curve looks like. And then this one is too, as well, I should say. We're going to talk about a time period. A lot of times your time period is one full circle. From 0 to 2 pi, 1 trip around the circle, all right? The bottom graph shows how many time periods? There's 4, right? They're called cycles. If you have 4 cycles, you go around the circle how many times? 4 times, right? So you talk about 1, possibly 2, but what they did was just show each graph, one a little more spread out, just so you guys could see a little bit. But let's just talk about this. A sine curve. A sine curve is always going to start, write this down, unless, okay, we're going to talk about this is without any shifts, without moving up and down, left or right. But sine, you want to think, starts at the x-axis. Starts at the x-axis. All right, now tomorrow, like I said, you're going to move left, right, up, and down. But you'll understand why I'm telling you to think that sine starts at x. So let's talk about this right, like we just went over. Here's my first point. What is the sine value? What is the y value at 0 or 2 pi of your unit circle? It's 0. Then when you go to pi over 2, what is it? There's your point. Then over at pi, what is it? 0. Then when you go to 3 pi over 2, what is it? -1. Then you come back to 0, 2 pi, and you're where? At 0, the x-axis. And that pattern just continues in a nice smooth curve. So what we're going to do today is we're going to identify the amplitude, how high and low the graph goes. We're going to identify where it starts. We're going to identify each little tick mark because it's not always just from 0 to 2 pi. The time period changes. We're going to mechanically show you and work on how to find those things. But you are going to then put it onto a graph. And I'll show you again as we go through this. We're going to put it onto a graph. All right, again, so those words, I want you guys to understand. I want you to listen to me. When I say amplitude, it's like the range, how high and low. When we talk about time period, it's from where we start to where we finish. When we talk about increments, it's the little tick marks in between. Those are the words that we're going to be using. And every time you draw this, guys, it's really simple. Again, when we go over this, I know you're kind of looking at it like, huh? When we actually graph it, it's going to be a little easier. Now, what are we talking about? Cosine. Still looks like a curve, a wave, right? It goes like this. But there's some things that are different. What I want you to think about with cosine is going to start at the amplitude. And I'm going to talk about that in a second. We're going to talk about what amplitude and all that stuff means. But let's go back to our unit circle. What is cosine? X values, right? So at 0, when we're at 0, what is the ordered pair? Think about your ordered pair at 0, or what is the x value? It's 1. Then when I get to pi over 2 in the ordered pair, what's your x value? 0. Then when I get to pi, what's my x value? -1. When I get to 3 pi over 2, what's my x value? Then when I get back to where I started, what's my x value? 1. So that smooth curve is just showing you one trip around your unit circle. Does that make sense? We're always going to be finding our increments based on fourths, because how many quadrants are there? 4, okay? That's what we're thinking of. Again, your amplitude is your range, how high and low. And we'll be able to figure that out here in just a second. So this is the mechanics of graphing. If you are given an equation, and we're not talking about things shifting left, right, up, or down, or anything like that, you can identify two things just by looking, the a value and the b value. A is the number in front of the function, right in front, stuck together. It's always going to be multiplied by, it's stuck together. A is your amplitude. Amplitude is half the distance between the maximum and minimum values of the function. What amplitude is how high and how low the graph goes. That's it. How high and how low. When you are asked on a test or a quiz to identify the amplitude, look what it says right here. Given by what? Absolute value. What does that mean your answer always is? Positive. So if there's a negative in front, you know you're going to go negatively, and I'll show you what that does to the graph. But if they ask you what the amplitude is, it's always positive. The b value, this is your b value here. It is the number that is in between your trig function and your x value. It's always attached directly to the x. That's how you figure out the time period. Your time period is right here. That's over which you're looking at. It's going to be 2 pi divided by b. So in this case, what number, in both of these, the sine and the cosine, what number is in front of x? If it wasn't a b there, just on your parent graphs, what was it? 1. So you take 2 pi divided by 1. On the parent graph, it just said, like on the previous slide, if it just said y equals sine of x, you would say, okay, my time period is 2 pi divided by 1. So it's 2 pi. So what would your 4 increments be? If you're going from 0 to 2 pi, what are the 4 quadrants? Pi over 2, pi, 3 pi over 2, 2 pi. Right? Does that make sense? Your 4 little tick marks. So what we're going to do today is we're going to just find the basics of graphing. I like the way that Miss Corey does this. I do it a little differently with pre-cal, and I just did it my way with the first example and then her way with the second two, and her way was, I think, a lot easier to understand. We are going to find our key points right here. We're going to multiply by fourths. Because think, guys, how many quadrants are there? 4. The reason why she's multiplying by fourths. Notice she has 1/4, 1/2, and 3/4. Why does she have 1/2? Same as 2/4. If you guys want to think about it as times 1/4, times 2/4, times 3/4, times 4/4, that's fine. But if you see, oh, 2/4 is 1/2, that's fine. So we're going to identify the amplitude and the time period. And once I do 2 of these, you're going to be like, okay, I understand what you're saying. Then we're going to find the key points. Then we're going to plot. And then we're going to draw our curve. Okay, so this is what you guys need to show me on notability for your homework. Because all you're doing on WebAssign is picking the correct graph. So yeah, you could go through that really quickly. But I need to see on your notability attached to this, your screenshot, I need to see the actual graphs because you guys have to graph this next Wednesday. So let's look at what we're starting with. First of all, what kind of a curve are we doing? Sine or cosine? Sine. So I always like to tell myself, okay, where am I going to start? Do I start at the axis, the x-axis, or do I start at the amplitude if it's sine? X-axis. Write that down. That's going to be helpful. We're not moving left, right, up, and down. We're going to do that tomorrow. Now remember, let's talk about our A value, which is our amplitude, and we're going to talk about our B value, which is our number in front of the x. So what is your A? 4. So that is my height, guys. What's the highest point that this graph's going to go? 4. What's the lowest point it's going to go? -4. When you plot your points, it always goes amplitude, axis, amplitude, axis. There's no points in between. You're just going to go up, axis, down, axis, up, axis, down. Repeats the pattern. What is the number that's in front of x? 2, all right? That's your b value is 2. Why is that important? Well, we have to do two things before we can graph. We have to identify the time period over which we're talking. Your time period is 2 pi divided by whatever the b value is. So in this case, guys, the time period, we're starting at 0 and we're ending where? What's your b value? 2. So what is the time period that we're talking about? Just pi. Is that a whole circle? No, it's only half a circle. So now we're like, okay, we know where we're starting, 0. We know we're ending at pi, but I have to know what my tick marks are in between. So I think this is the best way to do it. Write a 1, a 2, a 3, and a 4. And the way that Miss Corey does it, and I think it's great, you're going to take your time period for the first tick mark. You're going to say pi times 1/4. What's pi times 1/4? Pi over 4. Good. To find the second one, I'm going to take my time period and I'm going to multiply it by 2/4. If you want to say 1/2, that's fine. I'm just showing you each fourth. So I get 2 pi over 4, which equals what? What is it? Okay, pi over 2. Perfect. Then I'm going to take my time period. I'm going to multiply it by 3/4 because I've got to find the third tick mark. What does that give me? 3 pi over 4. Good. And then I'm going to take my time period and multiply it by 4/4, which gives me 4 pi over 4, which simplifies to pi, which, guys, should always be what you end with, right? At the beginning, we said our time period was 0 to pi. So notice our last tick mark is going to be at what? At pi. Okay, so let's put our key points and everything on a graph. This is what I need to see for notability. All right, I have 0 here in the middle. What is my first tick mark? What's the increment? Pi over 4. Perfect. What's my second tick mark? Pi over 2. What's my third tick mark? 3 pi over 4. And what's my last tick mark? Pi. All right, so I have one full cycle to the right. Can I do one full cycle to the left? Sure. What's my first tick mark to the left? Negative what? Pi over 4. What's my second tick mark to the left? Negative pi over 2. What's my third one? Perfect. Negative 3 pi over 4. And then what's my last one over here? Negative pi. Great. What we're looking to see when you guys are doing your test is, do you have the correct increments? It's not always going to be pi over 2, pi, 3 pi over 2, 2 pi. Depends on the time period. But so did you do the math correctly? Do you have it on the graph right? So the next thing I'm going to look at is the amplitude. What did you guys say the amplitude was? 4. So how high does this thing go? How low does this thing go? It goes up 4 and it goes down 4, correct? Now the negative and the positive in front tells you direction. Just like if you have a negative parabola, what direction does it go? A negative parabola. A negative parabola points what direction? Down, right? So think about this. Is this a positive 4 or a negative 4? Positive. So again, remind me where we said we started. At the amplitude or the axis? At the x-axis. Okay, so I'm here at the x-axis. And my first point, do I go up to 4 or do I go down to negative 4? I go up to 4, and then I go back down to the axis for my next point. Then where do I go? Down to negative 4, and then I go where? Back to the x-axis. Perfect. And then you just mirror those points on the other side. When I go one increment to the left, I'm down here, and then I'm back to the axis, and then I'm up here, and then I'm back down here. And how do we connect our dots? Dot to dot or in a nice smooth curve? A nice smooth curve, and this is what your curve would look like. This is what you guys need to do on your WebAssign. All you're doing is picking the correct graph on WebAssign itself. I need to see that work. Yes, ma'am. I didn't skip it. At pi over 4, the value is up here. Your y value is 4. And then at pi over 2, your y value is 0. Then at 3 pi over 4, your y value is negative 4. And then at pi, it's 0. All right, let's go to the next one. There's you two more. What kind of a graph is number 2? Okay, I hear you say it's negative. Good. So what does that mean? It's going to go down, right? We're thinking that down. That's good. So cosine, talk about cosine. Where does cosine start? At where? The amplitude or at the axis? Okay, we're going to talk about amplitude. So since you guys said it's negative, then where are we going to start? At -2. Perfect. Good. All right, so your A value, your amplitude is 2. Remember, it's always the positive or absolute value. And then your B value is the number that's in front of X. What number is in front of X? 2/3. Okay, why is that important? Because we have to find the time period. Once you find the time period, you can then figure out the increments that are in between. Remember, your time period is 2 pi divided by B. So I'm going to take 2 pi and divide it by what number? 2/3. All right, what does that look like, guys? 2 pi times 3/2. So I have 2 pi times 3 is what? 6 pi divided by 2 equals 3 pi. So what is my time period here? 3 pi. Is it one whole circle, 2 circle? What is it? It's a circle and a half. Good. All right, so you're starting at 0. You're going to end at 3 pi. So I have to find out what my tick marks are in between. It's not going to be pi over 2, pi, 3 pi over 2. So I'm going to find my tick marks. I'm going to take 3 pi and multiply it by 1/4. I'm going to take 3 pi and multiply it by 2/4. Again, you can put 1/2. I'm going to take 3 pi and multiply it by 3/4. And then for my last one, I'm going to take 3 pi and multiply it by 4/4. What should my last tick mark be? 3 pi. Okay, good. So when I multiply 3 pi times 1/4, what do I get? 3 pi over 4. That's my first tick mark. Then I'm going to take 3 pi and multiply it by 2/4. I get 6 pi over 4, which becomes perfect, 3 pi over 2. Then I take 3 pi times 3/4, and I get 9 pi over 4. And then 3 pi times 4/4 is 12 pi over 4, which is 3 pi, which is exactly what we wanted. So the math behind this is not hard, guys. Why are we multiplying by 1/4, 2/4, 3/4, 4/4? Each quadrant. Good, each spot. So now we're going to just graph it. Just takes a second to figure all the stuff out. We're going to find the positive side and then mirror it on the negative side. So my first tick mark, I'm going to put what? 3 pi over 4. Perfect. My second tick mark. Perfect. 3 pi over 2. My third tick mark. 9 pi over 4. And my last tick mark. Positive 3 pi. And now I'm going to mirror on the other side. So my first tick mark to the left is negative 3 pi over 4. Then I have negative 3 pi over 2. Then I have negative 9 pi over 4. And then I have negative 3 pi. What was my amplitude again? 2. So how high do I go? Up 2. How low do I go? Down 2. Okay? -1, -2. Now this is why I think it's really important at the beginning to say, hey, where do I start? Where does my graph start? All right, guys, so remind me again, where does this graph start? Are we starting at the axis or at the amplitude? We're starting at the amplitude. What kind of a number is in the front? Is it a positive or a negative? It's a negative. So where, ladies and gents, when x is 0, where is my first point going to be? At -2. Perfect. Remember, when we graph, it's a pattern. It's going to mirror itself. So I'm starting at -2. Then at my next increment, my 3 pi over 4, I hit the axis. And then I go where at 3 pi over 2? Up to +2. And then I go back down to where? To 0, to the x-axis. And then I go where? Perfect. Very good. So now we're going to mimic those points on the other side. So I'm going to go here to the axis, up here, down here, down here. And how do we connect our dots? Do we connect it like when we were 5 and we were doing our connect the dots? No, a nice what? A nice smooth curve. So we just go just like this. So perfect. And that's your cosine curve. So what we're looking for tonight on your homework with Notability, Your test next Wednesday. I am looking for you guys to identify the time period, for you to identify each tick mark, each increment from one to the next. Again, why are we doing fourths? Because of the quadrants. There's 4 quadrants on our unit circle. You need to pay attention to the directions. If the directions say over 2 full cycles, that means 1 to the right, 1 to the left. We're going to talk tomorrow. I have one more example. We're going to talk tomorrow about phase shifts, meaning that's how we move left to right, horizontally. And we're going to talk about vertical shifts. That's how we move up and down. So let's go to the next. And then I'll stop yapping and let you guys work. So what kind? Let's identify. What kind of a curve are we talking about? Sine. Why is that important? Tell yourself, where do I start? At the x-axis. At the x-axis. Guys, right here. Come on. At the x-axis, right? What's my A value? What's my amplitude? How high and low do I go? 1/2. Perfect. Guys. All right, so my A value, the highest I go is positive 1/2. The lowest I go is negative 1/2. So that negative in front is telling me, you guys already said we start at the x-axis. So I'm going to start at my x-axis, and I'm going to go what direction from my first point? Down. Why is it down? Because it's negative. Perfect. Okay, what's your B value? 3. Why is that important? Because that's going to help me find my time period. Your time period is 2 pi divided by B. So it's 2 pi divided by what number? 3. All right, so this isn't even half a circle. Or is it? It's a little bit more? A little bit less? What's 2/3, guys? A little bit more, a little bit more. 2/3, guys. 0.66667? Ish. I just want you guys to envision. I just want you to envision. So, I have my time period. I know where I'm going to start at 0. I know I'm going to end at positive 2 pi over 3. But how do I find the tick marks in between? I'm going to write down a 1, a 2, a 3, and a 4. And I'm going to take my time period, 2 pi over 3, and I'm going to multiply it by 1/4. So I get 2 pi over 12, right? Which is pi over 6. Then I'm going to take 2 pi over 3 and multiply it by 2/4. If you want to say 1/2, yes, that's the same thing. So 2 times 2 is, I get 4 pi over 12, which becomes pi over 3. Then I have 2 pi over 3, and I'm going to multiply that by 3/4. Gives me 6 pi over 12, right? Yes? Okay, so that becomes what? Pi over 2. Then I have 2 pi over 3 times 4 over 4, which gives me 8 pi over 12, which reduces to 2 pi over 3, which isn't that what we wanted to happen? Yeah? Okay, just make sure. So now, look how easy that was. Do this tonight on your homework. It's very, very simple. Just get in the habit of doing it. If you want to always start off with your amplitude, that's fine. How high does this graph go? Positive 1/2. How low does it go? Negative 1/2. Write your increments out. My first tick mark, you guys told me, was pi over 6. My second tick mark, pi over 3. My third tick mark, pi over 2. My fourth tick mark, 2 pi over 3. Agreed? Now we're going to mirror that on the left-hand side. So I have negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3. All of these graphs, I know, look very similar. What we're going to be looking for is the actual math behind the increments and where you guys start your graph. Remind yourself again, go back to the top. Where do we start? At the x-axis. So I'm going to start right here at 0. And it's a negative 1/2. So where's my first point? Down. And then I go back to the x-axis. And then I go up. And then I go back to the x-axis. And you're going to mirror that on the other side. So it just creates a nice, smooth curve. And we connect just like that. So tonight on your homework, guys, I am going to go through everybody's homework submissions. And if all you do is give me a screenshot of a score that says 100 and all of these questions marked correct, and there is not graphs to support it, you're getting a 50. Just make sure you practice this. You are going to have to do this on your test. I can't wait to grade it. Said no one ever. All right, look at this we're going to go to tomorrow. What do you think this +2 does to the graph? It moves all of the points where? Up to. What do you think this -3 does to the graph? Down. You can also have, it could also be written like this, like if you had y equals 2 plus sine of x. That doesn't become the amplitude. What's your amplitude there? What number is right in front of sine? 1, right? It's always the number right in front. That's just a shift up and down. What I like to do, I'm not sure how Miss Corey does it. I'm going to look at her video and see. What I like to do is graph the parent function, just like we just did. Those are all like parent functions. And then I would just shift each point up 2 or down 3. Sometimes it's easier to do that. You have like your original, and then you just move each point, so it's really easy to see. But we'll talk about that tomorrow. All right, your web assign is up. It is not due until Friday, but you can do the first 7 questions right now.